Hello and welcome to this video tutorial on how to implement a solution for finding the number of good paths in a graph. First, let's understand the problem statement. We are given a set of nodes and a set of edges between them, and a value assigned to each node. Our task is to find the number of good paths between nodes, where a path is considered good if the maximum value of any node in that path is less than or equal to the maximum value of any other node in the path. Before diving into the code, let's first talk about the union find data structure that we will be using. Union find is a data structure that keeps track of a set of elements partitioned into a number of disjoint, non-overlapping subsets. We use it here to keep track of the connected components in the graph. Now, let's take a look at the code. The first thing we do is initialize some variables such as the number of nodes, edges and the answer variable. We also create a vector called freq which will store the maximum value and the number of occurrences of that value for each node. The first for loop iterates through all the nodes in the graph. For each node, it sets the value of the parent vector at that index to be the index itself. This is because each node is its own parent in the union find data structure. It also sets the value of the freq vector at that index to be a pair of values, the first value being the value of the node as represented by the vals vector, and the second value being 1. The first value represents the maximum value of a node and the second value represents the number of occurrences of that value. Next, we use the sort function to sort the edges based on the maximum value of the two nodes that the edge connects. The sort function takes 3 arguments, the starting and ending iterator of the vector to be sorted, and a comparison function that takes 2 elements of the vector and returns a Boolean value indicating whether the first element should come before the second element in the sorted order. In this case, the comparison function is defined as a lambda function, which takes 2 elements of the edges vector, represented by the variables a and b. It calculates the maximum value of the 2 nodes that each edge connects by taking the maximum of the values at the indices represented by the first and second element of the vector. It then compares these maximum values and returns true if the maximum value of edge A is less than the maximum value of edge B and false otherwise. This way, the edges are sorted in ascending order of their maximum value, and in the for loop, the edges with lower maximum values are added to the graph first, which guarantees that the maximum value of any node in a path is less than or equal to the maximum value of any other node in the path. We then have the getParent function which is used to find the parent of a given node. It uses recursion to traverse the parent until it reaches the root node, which is the node that has itself as its parent. Now, let's see the function called getParent that takes into arguments a reference to a vector called parent and an integer called node. The function is used to find the parent of a given node in the union find data structure. The parent vector is used to store the parent of each node. Each node is initially its own parent, so the value of the parent vector at the index of a node is the index itself. The function starts by checking if the value of the parent vector at the index of the given node is equal to the node itself. If it is, then the node is the root node, meaning it has itself as its parent, so the function returns the node. Otherwise, the function recursively calls itself with the parent of the current node as the new node, and updates the value of the parent vector at the index of the current node to be the parent of the current node. This is also called path compression, which is used to improve the time complexity of the union find data structure. Finally, the function returns the parent of the given node. This function is used in the for loop to find the parents of the 2 nodes that the edge connects. Now, We use an if-else statement which starts by checking if the maximum value of the two nodes represented by the indices P1 and P2 in the freq vector are not the same. If they are not, it then checks which one is greater and updates the parent of the node with the lower maximum value to be the parent of the node with the higher maximum value. However, if the maximum value of the two nodes is the same, it updates the parent of one of the nodes to be the other node, and adds the number of occurrences of the maximum value of the two nodes multiplied together to the answer variable, uns. It also updates the number of occurrences for the node that is now the parent to be the sum of the number of occurrences of the two nodes. Finally, it returns the answer variable plus the number of nodes. This is because the problem statement states that a path is considered good if the maximum value of any node in that path is less than or equal to the maximum value of any other node in the path, and so the answer variable will contain the number of good paths in the graph, and adding the number of nodes to the answer variable will give the total number of good path in the graph. And that's it. With this code, we are able to efficiently find the number of good paths in a graph using the union find data structure. I hope this tutorial was helpful, and if you have any questions, feel free to comment. Thank you for watching.